Okay, so hi everyone. Good morning, good afternoon. I'm Nir, I'm the CEO of Traceloop. I'm going to talk today a bit about getting RAG pipelines into production and how to monitor them properly. So for the agenda, we're going to talk a bit about OpenLLMetry, which is an open source for monitoring production LLM-based applications. We're going to do a short live demo. And we're going to talk a bit more about monitoring in production, which metrics you should look at, and how to set them up. So we're going to kick it off with OpenLLMetry, sorry. So OpenLLMetry, it's an open source project that we've developed. And as you can understand from its name, it's deriving from a really big and successful project called OpenTelemetry. OpenTelemetry is an open source project. It's maintained and built by the CNCF, so the Cloud Native Foundation, which is part of the Linux Foundation. And it standardized the way that companies can monitor production systems. Right now, it's supported by all major observability platforms. So you see a couple of logos here on the right, but basically every observability platform that is out there supports OpenTelemetry natively. So if you monitor your application with OpenTelemetry, you can connect it to whatever platform you're using, whatever platform you want. So let's start by talking a bit about the OpenTelemetry ecosystem. So OpenTelemetry is a protocol, and it defines three types of telemetries that you can monitor. First one is logging. So logging, I'm guessing that everyone is familiar with what logging is. Basically, arbitrary events that you can send from your system that tells us about something that happened. Usually, when we're talking about LLM-based applications, you'd want to send your prompts and completions through the logging protocol of OpenTelemetry. Next one is metrics. So if you want to look at something on aggregate, like token usage, latencies, error rate, etc., you want to use the metrics protocol. And then this standard protocol lets you then slice and dice those metrics according to different attributes. Say you want to look at token usage for a specific model, or you want to look at latency based on a specific provider. Then using the metrics protocol within OpenTelemetry can make it really easy for you to do that. And lastly, you have tracing. So tracing is basically being able to track multi-step processes. So let's say you have a RAG pipeline, and you wanna see how much time took the query to Pinecone versus the call to OpenAI versus the call to OpenAI for creating the embeddings, or wanna see how much time it takes you to index different documents. Then these are usually multi-step processes that you can track and monitor through by using the tracing API of OpenTelemetry. So these are the three telemetry that you can use with OpenTelemetry. And if you use this protocol, then as I said before, you can connect it to whatever observability platform you're using. The OpenTelemetry ecosystem is pretty big. It supports a vast amount of languages. Currently, I think right now it's even more than 11, but last time I checked was 11. Different programming languages supported, including Python, TypeScript, Go, Java, C++, and others. And the main thing that you'd find in this ecosystem is what it's called instrumentation. It's basically a pre-made SDK that allow you to automatically send logs, metrics, and traces for different components of your system. So let's say you're using a Postgres database, and if you're using the Postgres instrumentation, then you'll get automatically logs, metrics, and traces for your Postgres DB calls. And lastly, the ecosystem includes something which is called the collector, which is an open source project that you can deploy to your system and do some post-processing to those telemetries before you send them out to an observability platform. We'll talk about them in a minute, but the idea is that they provide you with a way to do some post-processing or connect to multiple observability platforms pretty easily. So let's talk a bit about instrumentations. The idea of an instrumentation is basically an SDK that you install into your application. And what it does behind the scenes is that it monkey patches some other library. It hooks into outgoing requests and incoming responses, and then produce the telemetries supported by OpenTelemetry. So if you're instrumenting the SDK for Postgres or like say MySQL SDK, then you'd get, by installing the MySQL instrumentation, you'd get it will monkey patch all the queries you send to the database, and will send out logs and metrics and traces about different aspects of this process. Everything happens on the application side, and it's written in a super efficient way. OpenTelemetry already handles, production scales of billions of requests and billions of telemetries. So you should expect zero latency effect on your application. Basically, it's the lightest way of monitoring your application. It's very, very non-intrusive. Collectors is the second component that I wanted to discuss as part of OpenTelemetry. Basically, these are, as I said before, these are ready-made components that you can deploy into your cloud environment, into your production environment. And you can send all the data, all the traces, metrics, and logs that I mentioned before. You can send them into this collector that you deployed, and then you can configure within the collector a lot of things you want to do with these telemetries before you send them outside of your environment. So let's say you want to obscure some PII, some sensitive data that you have, or you want to filter out some data because it's not relevant and you want to send less data volume out of your cluster, or you want to send out data to multiple observability platforms because you want to use Sentry and Datadog or Traceloop and Datadog in parallel, then you can do it within the collector. And everything is super easy to configure. Basically, the collector has this huge YAML configuration that you can just, by changing two lines, you turn on some filtering, and by changing another two lines, you just send out the data to another sink or another destination. So definitely check out, search for OpenTelemetry collector. It's also really easy to deploy. So far we've talked about OpenTelemetry. So it's a standard protocol. It has traces, metrics, and logs, and you can use it to basically observe, any cloud-based production system. So we love this technology, and I think it's super useful and something that we've been using ourselves in the past. So we thought, okay, we can take this amazing technology and basically extend it to support the LLM Gen AI world, and add support to different components and SDKs we know people are using when they're building Gen AI applications like RAG pipelines, chat apps, and others. And this is OpenLLMetry, basically. So it's another open source protocol. It's fully compatible with OpenTelemetry, and it added support for foundation models like OpenAI, Anthropic, Cohere, Gemini, AWS Bedrock, and many, many others. Vector databases like Pinecone, and also frameworks like LangChain, LlamaIndex, and Haystack. And it basically works the same as OpenTelemetry. You install the SDK, and it automatically connects to all these different SDKs that you have installed in your system. And it produces the logs, metrics, and traces you can then view in your favorite observability platform. So if you have, you're using OpenAI and you're connecting it to Pinecone and building a RAG pipeline by installing the SDK, the OpenLLMetry SDK, you basically get all the observability you need to understand what's happening in your system. Since we're on a Pinecone webinar, we're gonna talk a bit about what we offer for Pinecone. So Pinecone instrumentation instruments everything relates to the calls you're making to Pinecone. So whether you're indexing new documents or running queries as part of a RAG pipeline, you'll get to see metrics and traces that show you how these processes work, what are the latencies are, and even being able to see the actual vectors and responses you're getting from the database. And you can also look, as I said before, you can look at latencies, so you can keep track of the latencies of your queries with database. And we'll talk a bit about this later. Pinecone also responds with things like the scores. So let's say you run a query to the vector database with some query, and you've gotten back some documents. Then Pinecone also provides you with the scores for these documents, which is a proxy for how closely related are these documents of the original query you sent. So we also track that, and this is something we'll see in a moment. Will be really useful for you to keep track on how well your system is performing and help you detect hallucinations. So before we move on, I think it's a great time to do a quick demo of a RAG pipeline with Pinecone and Traceloop and OpenLLMetry. So I'm going to pass it back to you, Zach.
Awesome. Thank you. If you don't mind, I'll take over screen share. Thank you very much. And let's dive in. So let me know if you can see my screen okay.
Yes.
Cool. Thank you. All right. So what we're looking at here is a standard retrieval augmented generation pipeline. So imagine everything that's on the left of the diagram as the pre-processing phase, right? So we are going to ingest a bunch of technical papers about Llama 2. They go through the embedding model from OpenAI, and then they land in Pinecone as vectors. Everything on the right side is the RAG query pipeline, where a user is going to issue a query in natural language. We are going to first convert their query into embeddings, send those to Pinecone, get back the most relevant related items that are most relevant to their query. And then our RAG chain is going to pass that along with a prompt to our LLM and ask for a completion that finally goes back to the end user. And notice here that throughout the entire process, OpenLLMetry is sort of seamlessly baked in here. So if we encounter any issues along the way, or slowness, or low relevance scores, as Nir shared, then those will end up in our traces, and we'll be able to diagnose the problem. So if we
just a quick note, I'm sorry to interrupt you. There are a bunch of people in the chat saying they can't quite hear you. I don't know if you can still increase your mic volume.
How's this? Is this any better?
Yes, I think so.
Okay, apologies. Just to quickly reset here. So everything to the left on this diagram is the pre-processing or ingest phase. So we're going to read a bunch of technical papers about Llama 2, pass them through an embedding model from OpenAI. The result will be vectors that represent the semantic meanings and structures in those papers, and those go into Pinecone, which creates our knowledge store that's going to back our entire RAG pipeline. So everything on the right side of this diagram is the user-facing RAG-backed query flow. So imagine there's a user here, they're asking a question in natural language that's going into our RAG chain. We're converting their natural language query to embeddings. That's called a query vector. The query vector goes to Pinecone. Pinecone returns to us the most relevant documents related to the user search. And then our RAG chain uses that when asking the LLM for a completion by passing the context of the items that came back, plus the actual prompt, and the response then goes to the end user. But notice that throughout all of this process here, OpenLLMetry is seamlessly integrated. So if we run into any issues or have exceptions or low relevance scores, then we'll find those in our traces. So if we step over here to this Jupyter notebook, and we will make this available in open source after the webinar in case you want to use it yourself. Initially, we just installed the Python dependencies we're going to use. So it's mostly LangChain, OpenAI, the Pinecone client. TickToken is a tokenization library. And so, not a ton of code that we actually need to get up and running here. And then once that's done, we're going to pull down the data set that has Llama 2 papers. And now, obviously, you don't need to do this. You could use any proprietary data that you have or your company has. It's just for the purposes of demonstration. This is how we set up the embeddings model. So this is the model, text embedding 3 small, from OpenAI that's going to convert the data, the text data in this case that it sees, into vectors. And then you can see with just a few lines of code, we can also initialize Traceloop. Quite easy. It's really one line of code, and then we're good to go. And Traceloop is intelligent enough to monkey patch all the calls that our program is going to be making to these third parties, including the Pinecone client, OpenAI's client, etc. In this cell, we're going to configure Pinecone. So in case we need to create a new index, we're setting up a serverless spec, as it's called. So this will create a serverless index. And if you're not aware, Pinecone now has a serverless offering, which is GA. And the key innovation there is that you no longer need to describe or know the size of your workload upfront. You can just write data and everything will scale infinitely under the hood. So with a working Pinecone client, the next step that we're going to do in this cell, note that we're setting an index name, Traceloop RAG. We're going to check if that index name already exists in our account. And if it doesn't, create the index. And we're setting the dimensionality 1536, which matches text embedding 3 small. But in this case, this loop is going to essentially detect that we've already got the index. We don't need to recreate it. And this is the piece that I find trips people up a lot. This is where we're actually looping through our data. So we create, we format our data in a way that's nice to iterate over using pandas. And then we have this, this code that's essentially going to output a progress bar. But the main thing that I want to draw your attention to here is that as we are upserting our vectors, we are also creating this metadata object and attaching it to each vector that we upsert. And so think of metadata as an arbitrary JavaScript object that you can use to store any extra information that will help enrich your application when you get it back. So in this case, we're just going to see the text, the source, the title of the paper from that we were citing when our RAG pipeline returns relevant results. And I'm not going to run this again because it takes 4 minutes and we've already created the knowledge store. So for the purposes of brevity, we'll just move on. Here you can see that, again, in just a few lines of code with LangChain, we can initialize a vector store class, and that handles everything that we need to do under the hood as well for writing and upserting, converting first data to vectors and upserting those vectors to Pinecone. And here's where we get to the real kind of the marriage of Traceloop and then all these various services that we're calling. So in this cell, we're going to define a function, and that function is called RAG backed query. So it takes in a string. That string is going to be the user's query, such as, if you look below here, what is special about Llama 2? And the first thing that we're going to do is create an LLM chain, and that is going to use ChatGPT 4.0 and use our OpenAI key. And essentially, that is an abstraction or a wrapper around OpenAI's GPT-4 model. The second thing we're going to do is create a retrieval QA chain that accepts the LLM that we just created and then uses our vector store as a retriever, right? So in these few lines of code, we have essentially created a full RAG pipeline that we can query as we wish. But the important thing to note here is that you can import a Traceloop decorator, and then you can state that this workflow is named RAG backed query. And as we'll see in a moment when we are issuing these queries to our RAG pipeline, this makes it a lot easier to group together and understand the metrics and the tracings in your Traceloop dashboard. So the first thing that we're going to do with our RAG pipeline that's now built is we're going to ask it a question that we do know it's going to perform well on, because we can expect that a data set full of papers about Llama 2 will have relevant context to answer the question, what is so special about Llama 2? And so as we make that query, we see that we get back a result. And note that this has gone through the entire RAG pipeline that I described before. So our query was converted to query vectors. Those went to Pinecone. Pinecone returned the most relevant items. The LLM was fed the most relevant items in the form of context, wrapped in a prompt, asking it to complete this chat completion, essentially. And so then we get back a response that looks pretty good, right? Llama 2 is notable for its open source nature, performance, scalability, etc. So the real key here is what happens when we ask a question that we do not expect our RAG pipeline to do well in. And as you know, if you've got a RAG pipeline in production, one of the first things your friends and family members and customers and coworkers will do when you tell them that you have a RAG pipeline in production is go to that RAG pipeline and try to ask questions to break it. And so in this case, we're intentionally asking a question that we do not expect to be in context. And note that based on provided context, as we expect, the LLM says it doesn't have any relevant context. It can't really answer that question. So then the question is, what does this all look like if we jump to our Traceloop dashboard? So the first view here, when we come into the dashboard, you can see all the various environments that you've got your code deployed. You can filter by time, and you can immediately get a really nice overview of kind of what's happening. Everything from the amount of spend, right, on your LLMs based on your token usage, to average latency, soft faithfulness. So NLP faithfulness, this is a kind of high level sanity check about to which degree is your RAG pipeline answering questions with truthful facts, and to which degree is it not. Even the query scores coming back from Pinecone that describe the relevance of the items in that retrieval phase during the RAG pipeline are visible, and which means that you can set up alerts and monitoring on it. So if you're coming from an observability or SRE background, this should be very comfortable. And then the really nice thing that I really appreciate the most is tracing. And so if we come in here and take a look at some of our traces, we can either do it in the last 30 minutes or we can do it live. But the traces are going to show us essentially everything that happened in our workflow. And that's why this decorator that we use becomes important. So you can see RAG backed query, just as we saw, the amount of time the entire workflow took. And immediately you can see, okay, well, embeddings, that was pretty quick. Pinecone query, that was pretty quick. But the chat completion for OpenAI, that was where the lion's share of the time was spent. And if you come here, you can see the full prompt that the LLM was sent. You can see the context that we passed. You can see the actual question. You can see the completions. And you can get really granular even about the amount of tokens that you passed and used, and how much that's likely to cost you. So if you have deployed a production RAG pipeline, as I have, then you know that step one is building the thing, designing it correctly, deploying it. Step two is ensuring over time that it's actually working, and some sort of observability tool such as Traceloop is really critical to doing that. And there's a bunch of other views here too that Nir is definitely more qualified to speak to, but you can also even monitor your prompts here and also evaluations. So pretty powerful, considering that it was about one line of code to initialize Traceloop in our example program. All right, and I think with that, I will pass it back to you, Nir, and unless there's any questions that we wanted to field right now, or we can save those to the end. But let's see if there's one other thing I wanted to share. Oh, there is a new chapter in this free ebook that we created called Vector Databases in Production for Busy Engineers. It talks about RAG evaluation, various metrics you can use, and then it has recommendations around various providers, including Traceloop. So if you're kind of trying to get deeper into RAG evaluation in general, recommend checking that out, and I will drop this in the chat as well. And with that, I will pass it back to you, Nir.
All right, so I see two questions that we can address very quickly. So first, can you send us the code notebook? So Zach will share the GitHub, we'll post it to GitHub so everyone can access it and run it themselves. And for on-premise, then yeah, of course, this can also be installed on-premise, and you can contact us through the website, through our website, if you want to discuss that. I know, Zach, you mentioned you walked briefly around like the metrics, and I want to deep dive a bit into like what types of metrics, what kinds of metrics we want to look for and monitor when we're deploying a RAG pipeline into production. But before we dive into the different types of metrics that you want to set up, we should briefly discuss the difference between monitoring, which is in production, versus evaluation in development. So the idea is that you're building your first RAG pipeline or your LLM application, and you wanna you're experimenting with different prompts, with different models, with different configurations, architecture of the pipeline, and during this time you have a few toy examples that you use, and you run your application against these toy examples, and you look at the response. Sometimes you can just look at it with your own eyes and see if it satisfies you or not. Sometimes you can run some framework that automatically validates the outputs, and at this stage you probably don't care if each run of this evaluation costs you a bit, because you don't run it on a lot of examples. latency is not that important because you're willing to wait a few more seconds to get the right response. Again, you don't have a lot of examples, so it won't take a lot of time anyway. And a lot of time you have ground truth. So basically, if you're building a Q&A system and you're trying to ask it a bunch of questions, you know what should be the right answer, right? For those questions you created. So you have what we call like the ground truth, which is something you can use to compare it against the responses you've got from the model. As opposed to all of that, when you're in production and you want to do monitoring, you first have much higher throughput, right? You have thousands or millions or even billions of users using your application. This means that the cost for evaluating each output, like checking the quality of each output, should be near zero. Otherwise, you won't really be able to make sure everything works well at scale. Latency is much more of an issue. So even something that can take a few seconds, it may be too much for you, especially if you want to be able to monitor your application in real time and even like stop bad responses from getting back to your users. So for example, if you want to check for hallucinations, you may want to block certain hallucinated responses because you have a really sensitive application. And then the latency would be super important. You can't really hold back the answer for a few seconds each time just so you can check properly that there isn't any hallucination in that answer. And of course, you don't have ground truth. You have no idea what the user is going to ask, so you have nothing to compare it against. Like if you run a RAG pipeline, you get an answer from the model. You don't know what is the right answer. You have to look at it yourself. Like there's no way for you to know what the users will ask, and then you have no way of knowing what would be the right answer. So let's talk a bit about metrics. So production metrics. So what types of metrics you should monitor when you're in production? We'll start with the easiest ones. Engineering. I call them engineering metrics. So if you've built any cloud-based application, this is something that you always need to look for. Latency. You want to make sure, like as Zach showed you, how much time each step in your application is taking. You want to monitor the calls to OpenAI. You want to monitor the calls to the vector database. You want to make sure that you don't have any glitches or increases in the latency, which can affect the overall performance and the user experience for your users. You also want to monitor cost. Sometimes you want to monitor cost and maybe like slice and dice it according to your users. So check out, see how much each user costs you, especially if you're using the newest models from some of the LLM providers. Cost can increase pretty significantly, and especially as your pipeline becomes more and more complex, you're going to have more and more calls to an LLM provider per each task that you're running for your user, and then cost can increase pretty significantly. And lastly, of course, you want to monitor for errors. And from my experience, this is the most interesting part because there are so many different errors of things that can happen, especially around the calls to LLMs. We've noticed, OpenAI, for example, erroring on many different things we even didn't think could fail. Like, for example, if you're sending two prompts too close to each other, which are similar, even if they're not exactly the same, sometimes OpenAI can block you because they're trying to avoid, burst calls. So you should definitely monitor for errors because this is likely a reason why your pipeline is failing for your users in production. Next thing that's also pretty easy to monitor is what I call the providers metrics. There are many different metrics that the providers send out in their different responses and requests, which you can monitor. And by the way, these monitors and also the ones I showed previously are all available with OpenLLMetry. So basically, once you install the SDK, you get all of these out of the box. But the two things that providers are providing, and I want to mention here, first is the Pinecone scores that we also talked about before. It's a really zero cost way for you to tell whether there's a potential for hallucinations. So for example, like the example that Zach showed, when we ran the query asking about Gemini on a document base which only contained data about Llama 2, there wasn't any document that could answer this question. So one thing you can easily notice is that the Pinecone scores, the scores for the documents you've gotten back, then you sent as context to OpenAI, were much lower than in normal operations. So this can be a really, really easy way and you know, a low-cost way for you to figure out whether there are hallucinations. Hallucinations can occur even if everything went right and the documents were relevant, but if you've got a question where there's no possible answer in your corpus of data, then of course you're going to get a hallucination, or you're just going to get a bad answer from the LLM. So looking at the score is a really good way to monitor for hallucinations, for example. And the other thing I want to also mention is OpenAI log props. This is something that is not available by default. You actually need to explicitly ask OpenAI to send you back in the response when you call it. But it's super useful because it gives you a proxy of how confident, let's say, the model is in the responses it returned to you. So again, if you're getting, I wouldn't say necessarily low, but if you're getting out of the ordinary log props, same as scores, if you're getting, nobody will tell you, yeah, 0.8 is a good score and 0.6 is the bad score. It's really depending on your use case. But if you're getting out of the ordinary scores or log props, then something might be wrong with this specific request or this specific run. And you should definitely monitor them and look for anomalies there. And the last part, I want to talk a bit about NLP metrics. And this is a bit more tricky because, as I mentioned before, you can use, sometimes even using the metrics you're getting out of the box is not enough. Everything, all the scores can look fine, and the log props can also look fine, but still there's a problem. There's a hallucination. There's something that's not working as intended for a specific request or a specific user, and you need a way to know that. And so right now, if you look at the natural language processing, the NLP metrics world, you have these two different types of metrics that are available. One is the classic NLP metrics, one that's been around for many years. I'll say many is like 7 or 8, but not more. So some of them are like the blue metric and the golden metric and the BERT score, which will basically give you a good way of assessing different aspects of quality for different tasks like translation or summarization and others. And with the increase of usage of LLMs, we've basically discovered that LLMs can also be used as a tool for evaluating quality. So we can use those LLM as a judge metrics like faithfulness and relevancy. And what's great about these LLM as judge metrics is that they closely relate to human judgment. So they're pretty good. Like if you can use them, you should definitely use them. The problem is that they're using LLMs. So basically it means that if you want to use them in production, for every LLM call that you're making, for every response you're getting from OpenAI, for example, you'd need to make multiple LLM calls to assess, to score the output that you've got. And it doesn't make sense. It will cost you a lot of money. You won't be able to actually do that for every request in production. Yeah, I mentioned it before. So it correlates really well with human judgment. And so if we go back to what I said at the beginning of this, then we need to figure out a way to, when we do run something in production, the cost must be near zero, because otherwise we won't be able to actually assess the quality of every output that we are getting. So what should we choose? Should we use the classic metrics or the LLM-based metrics? So the LLM-based metrics are expensive, like I mentioned, but they correlate with human judgment, so we do want to use them. We also, when we're using metrics that are based on large language models, it's kind of a given that they will be better than any other metric that we've seen. because they were trained on huge amounts of data. They correlate well with human judgment, as I said, and they're also very intuitive. Like if you look at the implementations of things like RAGAS, for example, which is specifically for evaluating quality for RAG pipelines, you'll see that the idea of the questions that the LLM is asked are really intuitive. It's basically how you would assess the quality of an output you've gotten from a RAG pipeline. So it's no surprise that it actually works. So what we chose and what we've been working on, and I think this is the most interesting and promising path here, is using some combination and some tweaks on classic metrics to approximate these LLM as a judge metrics. Basically, if we can show that those classic metrics or some combination of them correlate well with those LLM as a judge metrics, then basically we're good to go. We can use these classic metrics, which are much cheaper to run in production, and use them to assess the quality without running those expensive LLM as a judge metrics. And if you think about it, the only thing that you really care about is looking for errors, looking for mistakes. So basically, you don't need them to correlate completely, but you want to get this nice property where if the classic metric gave you a low score, then with high probability, the faithfulness metrics, for example, will also give you a low score. This means that if you got a low score for the classic metric, there's something wrong there. You may get some false positives, but most of the time it will mean that something didn't work there. So we developed this recently. We developed something which is called soft faithfulness, and we're gonna publish a nice blog post and a paper about it in a few weeks. And basically, we've been building upon these classic metrics and been using a combination of vector embeddings with looking at relations between vector embeddings to find relation between context and answer. So it's really useful for RAG pipelines and really useful for checking basically something which can be checked with RAGAS faithfulness. So checking if an answer you've got from an LLM closely relates to the context you've gotten from the vector database, from Pinecone. And what you can see here is that we try to look at how these two metrics compare. Remember, we have the RAGAS faithfulness, which we know correlates really well with human judgment. So when RAGAS tells us something is not working, when it gives a low score, we know that there's something wrong with the answer. And when we compare it to the Traceloop soft faithfulness we developed, we saw that, as you can see, when scores are below 0.5, most of the time it actually agrees with the RAGAS faithfulness. This means that, and by looking at the numbers, more than 85% of the times, the Traceloop soft faithfulness agrees with RAGAS faithfulness on the decision on the answer, so whether the answer is correct or not. And this is another data set that we also use, and you can also see that this actually works for many, many different data sets that we tested. So I think the take from here is that for production, we should look for metrics that we can run that won't cost us a lot of money, and we should look for ways to approximate those metrics which we know work well, but are really expensive to run. So RAGAS faithfulness is a nice example, but I think most of the LLM as a judge metrics you'll find out there from many open source libraries will give you a good sense of what you should aim for. But you should look for ways to use those classic metrics, which are much cheaper to run, and you look for ways to how to correlate them with those LLM as a judge metrics, so you can actually run them in production. Lastly, I just want to put here some useful links for things we showed you today. So OpenLLMetry is an open source repo. You can check it out. And this is our main website for the platform. And if you want to consult with me around metrics, then you can go to this link and we'll be we love to talk to you a bit more about. We have a lot of thoughts around, metrics and how to use those classic metrics. Yeah, I think that's it.
Awesome. Thanks so much. We got a couple of great questions here, and I think you may have already addressed some of them, but we'll just double check here. So there were two folks asking how does an LLM evaluate faithfulness, essentially? What's the mechanism inside the evaluation?
So
did you want to expand more on that, or?
Yeah, so we can talk about it a lot, but basically the idea is looking for, so the most naive part would be, to just ask an LLM a question. Okay, this is the context, this is the answer. Does this answer, can you find proofs for this answer in the context? This is like one way that you can potentially do. But another way that is really interesting is basically decomposing both the answer and the context into questions, into yes/no questions, basically. So taking like the answer, for example, and finding 10 answers, 10 questions that the answer let me start again. Taking the answer you've got from the LLM, like the generation, and generate 10 questions using another LLM, 10 questions that basically cover the content of that answer. So if that answer, like we saw in your example, Zach, explain to me what Llama 2 is, then I can generate 10 questions asking about different aspects of Llama 2 that are answered in that generation. I can then take those same questions and check what should be the answers in the original context. And I expect the answers to be the same, right? If if I've got some answer for like the generated content, it should be the same as the context answer to that to those questions. And if there's a mismatch, I know that there is a hallucination. So if you think about it, like it's a really nice way of figuring out, of comparing, faithfulness of an answer to a context.
Awesome, thank you. There's another question. With many evaluation frameworks out there, how do you narrow down on which framework to utilize for your use case? I can mention that in that article that I shared in the chat link, we do have some recommendations towards the end of that chapter with a table that includes like the various frameworks, including also Traceloop. So take a look at that. I would personally say it depends on your requirements, right? But Nir, did you want to speak to that as well?
So yeah, I think, as you said, like it really depends on the requirements, and I think again, it really depends on where you want to run them. If you want to run them offline or online, you should choose different frameworks. And it really depends, and yeah, I think it really depends on the use case. You'd find for different use case, different frameworks will better or not, and you should just look. Sometimes, even these frameworks have recommendations. Like Ragas is becoming really popular for RAG pipeline. So if you're a RAG pipeline, I would say Ragas is probably your go-to framework.
Nice, yeah, and like many things in engineering, it's there's a little bit of trial and error, right? So
yeah, exactly.
Okay, awesome. Another question is why soft faithfulness can be negative.
It's just the way, like you potentially can normalize it to between 0 and 1, but the way we calculate it, we get a score that can potentially be negative.
Cool, got it. What is the difference between OpenLLMetry and Traceloop? Are there any differences in features?
Yeah, so every metric that we can collect with basically 0 latency or 0 footprint on your application, we have in OpenLLMetry. So if you want to collect, tokens, cost, everything is there. For the more complex metrics where we need some model like the soft faithfulness that I showed you, these are only available on Traceloop because we need a bit more powerful machines to run them on, and we can't really run them in your production environment because they will be too expensive and will affect the latency of your application.
Awesome. Looks like the last one is Blue Rouge. When I used them, they gave low scores as RAG, not giving exact answer every time. So I switched to use RAGS. Am I in the correct direction, or do you have a different suggestion?
So I think it all goes back to what is the phase you're at. If you're during development, then yeah, RAGAS is great. But if you're in production, you can't really use RAGAS. You have to use some combination of these more economic metrics. And highly recommend trying out what we have on the platform. I think you'd find them, they closely correlate with Ragas and other LLM as a judge metrics, and they don't cost as much.
Awesome. And then another last minute question, maybe off topic RAG questions here, but with Microsoft's new recall feature, which I see as multimodal RAG, would there be multimodal RAG evaluation in the future? Is that your expectation?
Definitely, but I would say the question, like the output, like it's easy to evaluate text, but if you're not generating text, then running evaluations may become a bit harder. So I'm not sure if the one who asked, like, man, is asking about like using like images and other types as inputs or outputs, but like evaluating the output of like an image output is a whole different story than evaluating text.
Yeah, I could imagine it might, this is just me dreaming, it might be something similar to the trial of like, view these images, did you get the right answer, right?
Yeah.
And then eventually you might imagine running test suites across the whole spectrum of multimodal inputs.
Yeah, exactly.
Awesome. These are great questions. We really appreciate all the questions, and we really appreciate your time and attention, and all these excellent, thoughtful questions. And I hope this was useful. And I think if there's no more questions, the recording will be made available. We've recorded it, and we tend to put it on YouTube and then share it out. And then we can also share out the links and that I shared in chat here too, and maybe put them in the video. But yeah, otherwise, thank you all so much. Really appreciate your time. Thanks so much for coming. Give Traceloop and Pinecone a shot, and really appreciate it. Hope to see you in the next webinar. All right, thanks so much, Amir. Really appreciate it.